on this problem here, I really couldn't find one that was just like it. So I'm just going to talk about how you could think about this problem. So it's talking about a line that passes through this particular point and it has a slope of this, and which of the following points would also fall on that line. So it doesn't give you the equation that you can type in, but it does give you some information. So I'm going to come over to Desmos and start just thinking about it. And when I'm thinking about it, I like to actually look at what these points are. So I'm typing into Desmos that first point that I was given. And then I'm thinking about a slope of -2, 3. Now you could go ahead and plot these other points too. So you could plot 9, 5, and then plot each of those. Then come over here and look on Desmos to see if you applied that slope, a -2 up 3. Now remember, our original point was this one. If I apply this slope, will I get to that green point? Let's make it a little bit bigger so that you can see the boxes to actually count your slope of -2, 3, or negative. So negative, it means I'm going to have a line that's sloped downwardly, like a negative slope is like this, right? So if I'm starting at this blue dot, there's no way I can make my way up to that green dot. There it is. See, that's going the opposite direction. So I'm pretty sure it's not A. Now, as I said, you can plot each of these, and then you also just want to think about the slope, okay? So each one of these boxes is worth 1. So if I'm going up 2 and over 3, 1, 2, 3, that's where that lands me. And then up 2 and then over 3, and I could keep doing that until I run into one of these other points. So that's what I would suggest you do. You know, it's not A. I would plot these other points and then see if you will run into them by applying the slope. Now remember, a slope is, first of all, we said it was negative, and then it's a rise of 2, a run of 3. But I could go down 2 and over 3. I can do that, as well as I can go up 2 and over 3. And you can just keep applying that slope and see if you run into one of these dots. That's one way to do this problem. So if that's good enough for you, go ahead and do that. If you want to know the more technical, like mathematic way to do it, this is what you would do. Okay, so you're given a point and you're given a slope. So why not use point slope? So y minus y1 is equal to m parentheses x minus x1. That's point slope formula. And I'm going to put in this point, and I'm going to put in the slope and get an equation. Y minus the y value, so that turns into plus, is equal to -2/3 x minus a 3. Okay, and I simplify this by distributing. Negative times a negative is a positive. And now I'm going to have a positive 6 over 3, so that simplifies to 2. Subtract the 1, subtract the 1. Y is equal to -2/3 x plus 1. I can utilize Desmos by like typing that equation in and then plotting these other points and see what falls on them. Or again, I can just use regular old mathematics. If this point works in this equation, then it will make either side equal. So how do I check that? I would go, I would substitute in for the y and substitute in for the x. So substitute in -2/3 times -3 plus 1 is equal to the y value, which is 1. And you do that math and see if that's a true statement, and then you can keep doing that. So true statement would mean if it says 5 is equal to 5, well, that's a true statement. But if it's like 3 is equal to 5, nope, that's not true. It didn't work. That's what I mean by true statement. So you can try each of those. Those are all different methods that you can use in order to solve this problem.